Hi, I'm David Koepsell, National Utility Sales Manager at MBW, and today we're going to go over the Vapor Extraction Unit and do a training. Within this training, we're going to go over the PowerPoint, which encompasses the history of the unit, the theory of the unit, and then tips and tricks of how to operate the unit. Then we're going to dive into the nuts and bolts of the Vapor Extraction Unit, the proper setup of the unit, followed by the calibration of the sensor of the unit. MBW presents the Vapor Extraction Unit. The V.E.U. was invented by Atmos Energy in Dallas, Texas. An engineer by the name of Mark Chapman had the idea to extract natural gas from below ground efficiently and safely. Most gas extractors on the market offer no monitoring devices and perform poorly. Mark approached MBW's distributor, EGW Utility Solutions, with his vision. EGW then brought Mark's idea to MBW for a review to see if it could be done. After a few years of trial and error, MBW created the Vapor Extraction Unit for Atmos. The V.E.U. has three main functions. You can evacuate natural gas from below ground safely. We have added an LEL sensor that monitors LEL levels in real time while running the V.E.U. This is the only gas extractor on the market that can do this, pinpointing where your leak is in a widespread migration. You can run up to 18 probes at one time and control every probe and port with a shutoff valve. Once the V.E.U. is running for a little while, you will start to see the LEL levels decreasing in each bar hole. If one hole or multiple holes are staying consistent, then you have pinpointed the leak. In comparison to a Venturi or a Tornado, you will need 9 crew trucks running 2 Venturis to equate to the 18 probes running on the V.E.U. Also, the probes are 2.5 times more productive than a Venturi. One more key point is that the V.E.U. works in direct vacuum when extracting the gas. The Venturis and Tornadoes do not do this. They tend to move the gas around underground, creating little bulbs of air and not getting all the gas. This leads to moving the Venturi around multiple spots and revisiting the bar holes with the Venturi, because when you leave the bar hole, the gas naturally comes back to the hole with this method. The V.E.U. does not have this issue because of the direct vacuum. The V.E.U. gives you the ability to respond to an emergency gas leak and control the migration of gas. For example, you have gas building up outside of a business. You can bring the V.E.U. out to the scene and start extracting gas, which gives you the control of the migration immediately. This in return buys you, as the utility, some time to figure out what is going on while keeping the store open. This minimizes your exposure to the public. What would take the old tube type extraction machine a month, we can now accomplish in a few days, was said by Mark Chapman, the creator himself. Now, I do not want to make any promises on how fast or slow an extraction will be for these reasons. We do not know how much gas has migrated underground. Different soil conditions and caps play a major role in this process. We do not know if there are multiple leaks. Every leak is different and unpredictable. Some leaks you may find quicker than others that may have been going for longer periods of time. The V.E.U. is not a miracle worker, but it gets the job done the most efficient and fastest way possible. Having realistic expectations with the V.E.U. is important, but when compared to the old Venturi method, it is substantially better. Now I will play a short video of a tornado running off the utility truck's PTO. Notice how loud it is and how you can only run one unit off an air supply. The V.E.U. can run up to 18 probes and run under 90 decibels. Here is another alternative gas extraction machine. This is the air horn, and it runs off an 600 CFM tow-behind air compressor. This horn screams at 130 decibels plus while not being fuel friendly at all. The VEU can run 8 to 10 hours on one diesel fuel tank. You are probably wondering what makes a VEU work so well. First, it is powered by a liquid-cooled Isuzu diesel engine, which is Tier 4 compliant and meets every state's emission standards. This engine powers the blower. In between the engine and the blower, we have a flex rubber coupler. This coupler is designed to flex and shear. This coupler can fail if the engine or blower is running off or seizes up. It prevents you from losing an engine and a blower. The coupler is a quick couple $100 fix compared to thousands of dollars you would spend on a blower or engine replacement. Then we have an 850 CFM rotary turbine blower made by Tuthill. This works the same way as a turbo in a car or truck. This is where the magic happens for the vacuum. This combination allows it to be run at or around 80 to 90 decibels. MBW has incorporated a methane LEL sensor that monitors in real time the gas concentration going through the machine, which helps provide a safe environment for crew members. If the LEL goes over 35% LEL, an audible alarm will sound, and if the LEL level exceeds 50 LEL, the unit will shut off. The operator is given full control of the VEU through an air bypass valve that can adjust to ensure the LEL levels are safe. This sensor does need to be calibrated quarterly, just like any other gas detecting instruments. We do sell the calibration kit, which comes with the regulator for the cal gas, hoses and cups to connect to the sensor for the calibration process. The air bypass valve gives the operator full control of the gas extraction process, audible alarms, and VEU shutoff. This is done by starting the VEU with the air bypass valve all the way out. This is minimum vacuum and maximum air. Your goal is to have the air bypass valve all the way in, which would mean maximum vacuum and minimal air. The control board is shown here. This display shows the air bypass valve circled in yellow. This valve allows operators to blend fresh air with gas concentration to control the alarms and maintain optimal performance. The LED lights increase from green to yellow to red. This movement correlates to the LEL levels the sensor is detecting in real time. Recent improvements. Isuzu liquid-cooled 28 horsepower diesel engine that is Tier 4 compliant with most states' EPA and emissions regulations. Improved blower silencer. This machine runs between 80 to 90 decibels wide open. The silencer accessory has been discontinued from the manufacturer who provided us with it. The new muffler equates to what the old silencer used to do. The new mufflers are not available for first generation VEU retrofits. The lockable housing allows you to leave the VEU run and not have to worry about someone coming around and messing with it. The plug connection for the VEU has been improved over time. The connections on the first generation VEUs used to break, and we resolved that issue with a universal plug in for the VEU sensor, which improved the connection tremendously. We no longer have any sensor connections breaking. The LED lights have been added to the control board and the sensor. It is much easier to see where you are at in LEL levels when running the machine now. The control panel has come a long way. We added a user-friendly control board that tells the operator everything they need to know while running a VEU. It has the air bypass valve, LED lights, glow plugs, engine start and stop, and alarm test buttons. We have gone keyless with this machine. There is a pump oil spot on the VEU control board. This pump oil spot is a great place to spray 4 to 5 spritzes of WD-40 onto the machine port to lubricate the blower for long-term storage or preventative maintenance while pulling a lot of water. This little step will help prevent the blower from rusting up over time if it is not done. When choosing to use the VEU, there are some major cost savings associated with it. You will see decreases in the amount of dry holes. The days of misdigging and mispinpointing will be reduced because of the accuracy involved with each VEU probe. When running a series of probes off the VEU over time, the LEL levels of gas in each bar hole will decrease. The bar hole that stays consistent or is hot and is not zeroed out is where your leak is. The efficiency of using the VEU will expedite the extraction process tremendously. You are able to deploy up to 18 probes and cover a wider range of gas migration with one machine. The VEU allows the utility to respond to an emergency situation a lot faster and helps minimize your time in the public eye. Smaller road cuts and excavations are a result of the accuracy of pinpointing where your leak is underground. Each probe has an on-off valve and can be removed easily from the bar hole it is in to check your LEL levels or gas level readings. This, in return, allows you to pinpoint where a leak is efficiently and fast. Businesses and homes can reopen a lot faster with the VEU. The days of being on a leak for months at a time are reduced to weeks, days, or even hours, depending on what is happening underground. You can even keep businesses or homes occupied once the situation is under control and the VEU is providing a safer environment. The LEL sensor on the VEU is what makes this unit the safest on the market. The Venturi and Tornado and Horns or any other extraction methods do not have a way to measure what amounts of gas are being extracted in real time, nor do they have audible alarms or shutoff alarms on their units if the gas extraction process becomes unsafe. For basic field operation, take one of the covers off the VEU 1.25" ports. Connect and run one 25-foot section of hose off of one VEU 1.25" port to your first probe bar hole. Then place the remaining probes 4 to 5 feet apart by using the 5-foot hose provided in the probe kit. Drill your remaining bar holes, place your probes in the bar holes, and connect the hoses to them. Take the cover from the VEU 1.25" port and seal off the last probe to make it a series of 6 probes, which is the maximum per line on that port. If more probes are required, repeat the process until all the 18 probes are deployed. If you are not using the probes, please note that you can only use the 3-inch manhole port at a time and not supplement that with the series of probes off the VEU. It is a one or the other type of deal. Here's a typical placement of the VEU probes in a series. As you can see, we have the VEU set up between the home and the business and the gas main. Plume of gas is building up by the homes, so we need to get that away from them. We start running the VEU, and the gas starts to migrate towards each probe. As a result, we start to see the LEL levels and gas levels decrease near the homes. Each VEU probe can pull the gas from up to 60 feet away, depending on the conditions, said one utility who is testing to see how far they can pull gas from. The gas always takes the path of least resistance, which in the VEU's case helps it perform at higher levels by controlling the migration of gas at all times. Please note, do not place the VEU probes up against a building. The VEU, when running, could potentially have the gas pulled into that building. That is why we say to keep the probes set up at a safe distance from all buildings. As you can see, the probes are pulling the gas from the home and creating that safe environment. Probe 1 and Probe 6 are now zeroed out, and you are starting to see the accurate pinpointing process take place. Look at that plume of gas has been vacuumed out, and the leak is now found. It is on probe number 2 in the series of 6 probes. Please note that this is just one of many different scenarios that can happen when out on a gas leak. Here is another slide going over the extraction process from an underground view. The VEU is running and extracting the gas through one series of probes. Eventually, the gas is extracted and led to the number 2 probe being the hot hole where the leak actually is. Here are 2 pictures taken in the field of the VEU in action. In the first picture, you can see the VEU probes in a series along a sidewalk in the grass. No bar hole drill required because the ground was soft enough to simply push the probes into the ground. The second picture shows how the VEU can be hidden in the public eye. The VEU is behind the fence here and the noise is displaced even further from the customers. The self-contained VEU can be used in many different ways and applications. These are just some examples. This picture is from outside of a laundromat in Huntsville, Alabama. The utility had detected gas within the building here. We all know a laundromat and gas do not mix, so we had to bring the VEU out for this emergency. We set up the VEU and probes away from the building at a safe distance. We started running the VEU and could see the LEL levels being pulled away from the building. On this job, we ended up pinpointing the leak on the second yellow dot in the middle of the picture here. That day, the utility ended up purchasing a VEU because it responded so well at a high-level emergency. In this set of pictures, we were on a job that we could not get the VEU into the backyard of a customer. We had to run the hoses and probes from the road where the VEU was parked. You can see we placed the VEU probes on top of the highest readings of gas. The other thing to note is that we were able to string the hose all the way down the alleyway into the backyard and still maintain optimal performance on the VEU. We do have the capacity and capability to string up to 125 feet of hose to the first VEU probe and not lose any performance on this unit. This is a picture from Consumers Energy, and we were on a gas leak emergency a few days before the kickoff of a Michigan football game. The leak happened to be on the main drag by the stadium, and they could not take the chance of closing it for game day. We had 2 VEUs and put one on each end of where we thought the leak was to begin the pinpointing and locating process while only having to close one lane of traffic. We were able to pinpoint and locate the leak the day before the game, but the process would have been expedited if we had used 2 or more probe kits to cover a large area with this widespread migration of gas. Here's another set of pictures showing various setups for the VEU in action. As you can see, the probes are placed in the median on the upper right and then placed in bar holes in pavement on the bottom. The VEU probes can essentially be placed in any type of pavement or soil type. We need to just get below the cap that is preventing the gas from venting to atmosphere naturally. Tips for dealing with various conditions. In pavement or asphalt, you can place the probes in bar holes next to or in the pavement. In frost, make sure your bar holes and probes are below the frost line, and in some instances can be very deep. In clay, always try to be below the clay line if possible. This will expedite the extraction process. A rule of thumb is always to try to have your probes below whatever cap is preventing the gas from getting to atmosphere. In this slide, we were up north and had to get out the telephone pole auger to dig out bar holes below the frost line. The bar holes had to go 6 to 8 feet deep to get below the frost line. Now keep this in mind, this is a rare and extreme occurrence. This was a very cold winter in Wisconsin. Please note that we had to be creative and use plywood to seal off and cover the larger than normal bar holes for the VEU probes. This is a standard factory trailer for the VEU. This is a lightweight and easy to transfer trailer, making the VEU one self-contained mobile unit. In these pictures, there are a few trailer mounting options taken from around the country. As you can see, some of our customers have gotten creative with making the 3-inch manhole cover for the 3-inch hose option when using the VEU. Please make sure that these manhole covers are heavy duty, because when operating the 3-inch port, that gets the full 850 CFM of the blower as an all or nothing type of deal. If you choose to use plywood, please reinforce it because the fitting will shred right through the plywood when under load. This is a trailer setup I like to show off. This is one from Koepsell Energy, and they went above and beyond on the trailer setup. Diamond plated interior, space heaters, concession doors. The VEU comes out on tracks from underneath for maintenance. The probes and hoses are highly organized. The sky's the limit for transporting this unit. MBW has always maintained a customer focus, and if you notice anything that helps improve our machine, we will listen. Here are a few improvements made from over the years. We improved our engine from the original to meet the EPA and environmental standards. The engine is now Tier 4 compliant. We also have added an easy fill gas tank. The original designs were hard to access and fill the tank for the end users. The days of losing the keys are done. We eliminated the keys on the new units by making the VEU push to start and keyless. We improved the control board by placing it on the VEU itself and made it user-friendly to operate. We also added the control board cover to protect it from the elements and even lock it. The built-in silencer is now standard and the days of the loud machines are numbered. All of these improvements are from the field VEU operators across the country. We do offer probe kits that come with 6 probes, 5 5-foot sections of hose, and 1 25-foot hose. Trailer kit is available as well. Sensor calibration kits are needed to do the quarterly calibration of your VEU sensors. We highly recommend buying the kit. It includes the hoses, cups, regulator, and cal gas in a carrying case. The manhole kit comes with 4 5-foot sections of hose and a 3-inch fitting that can be fabricated to any manhole cover or lid. We do offer a spare parts kit that will help do most of the standard maintenance on the VEU. This kit includes a large oversized air filter, oils, a fuel filter, a coupler, and you can buy any replacement parts for the VEU as well. Please take the time to do the standard maintenance on this machine and follow the maintenance schedule that is spelled out in your VEU owner's manual. Here's a list of the current users. The VEU has over 300 units across the country, and they vary from the smaller utilities to the large utilities. Anyone can learn and use this machine effectively, and they will see tremendous savings in time and dollars. Feel free to check out our MBW.com to see our utility-specific machines such as the ErgoTamp, pressure tester, soil pack, and pneumatic air rammer. If you have any questions, feel free to contact me at 815-631-2212 or email me at davidk@mbw.com. Thank you. And now we're going to dive on into the components of the vapor extraction unit. Right here is the diesel fuel tank. You can get about 8 to 12 hours on a fuel tank depending on how hard you are running it. And then next to the fuel tank is the battery. Now when you order a new unit, the battery is disconnected. So if you do have a new unit, make sure you go out and connect the terminals on the battery before you take it out into the field. Next, we're going to talk about what is right here is the giant oversized air filter. It's a K&N air filter that filters out the debris and water that are running through the machine as you're extracting the natural gas. So you can put that back on right here, slide it on in, and then there are these covers and wing nuts that cover it up. So you put this on here, and then you put the wing nut on. And then you can put this other cover on to seal it completely. And then you use this wing nut here and seal it up. Now below this air filter is a sight glass window. This sight glass allows the operators to see what is actually going through the unit in terms of debris and water. So you can see what's going on in the unit in real time. And then you can also take off this wing nut and have it drain. And this comes right off. And you can put it back on, just like this. Now some utilities will take a ball valve and place that right here and run a piece of PVC pipe down behind it and then have an on-off valve to automatically drain back here. Here's the 3-inch manhole port, and then we have 3 1.25-inch ports. Now when running the VEU, you can either use 1 3-inch port or 3 1.25-inch ports. You cannot run all 3 ports and the 3-inch port at the same time. Another thing with the 1.25-inch ports is you can take this cover off and use it to seal off a probe for the VEU. And then you can also take it right off. On these ports you can see that there is an on-off valve as well, so you can control which ones are running and which ones are not. And then as you can see, the 3-inch port does not have a valve. So your control is the engine start and engine stop for that port. Here is your main power switch, which turns the unit on and off. Then we have an air bypass valve right here, which controls the amount of fresh air blending with the gas concentration, so you can push that in and out. Then you also have a throttle, which controls the engine speed. Then we have a pump oil spot right here. This is a place where you take your WD-40 and do 4 to 5 spritzes, and then let the unit run for 30 seconds and let it lubricate the blower, and you put the cover back on. Then you have a high alarm and low alarm here for lights that are correlated right here with green, yellow, and red. This correlates with what is happening within the unit in LEL levels. At 35 LEL, a low alarm will go off saying, hey, I need more fresh air within the unit to keep it running. And if the LEL level exceeds 50 or more, the unit will shut down and the high alarm will sound. Then you have your battery light, your engine oil light, your temperature light, and a wait to start light. And then you also have the glow plugs, which you just press with this button here. An engine start, so it's push to start. Engine stop, so you can stop the unit. And then a test alarm. You just hit this button and it'll test the alarm. And then lastly, when you're putting it away, you turn the power off and you put the control panel cover on the unit. And located here is the Isuzu liquid-cooled diesel engine, 28 horsepower, and it is Tier 4 compliant and meets all EPA and DNR regulations. Behind this door is an 850 CFM Tuthill blower, and that is where all the magic happens, where that vacuum is created to make the VEU operate. Here's the flex rubber coupler, which is a design shear point that is connecting the blower and the engine on the VEU. This is the LEL sensor for the vapor extraction unit that monitors in real time what is going on within the unit. This is the safety feature that controls the LEL audible alarms at 35L and 50L. And now we're going to go into starting and running the vapor extraction unit. The very first step when you get out to a job is to plug the sensor in. So you take the sensor out of your toolbox, take the cover off here, and then there's a little slit here that you want to line up on this groove on the bottom. If inserted properly, you will hear a click, and that is the O-ring sealing. And at this point, the sensor is going through its warm-up cycle and you can actually flip the main power on. And now the next step within setting up the VEU probes is connecting the 25-foot hose section to the machine itself. What my field member is doing is connecting it, and then he's going to run that 25-foot hose to the very first probe. And then he's going to connect each probe with a 5-foot section in between each probe. And then at the end of it, he will seal the series of probes off with the end cap. In the meantime, I like to discuss the length of hose to your first probe. We have tested and seen production of the VEU not dropping off from up to 125 feet of hose away from the unit. The other thing I want to mention is that we have modified our VEU probes over the years, and we've actually increased the efficiency of the VEU probe by 70% by just widening that top valve. Also, my associate is making sure as he's setting up that the VEU probes are all turned off. And here is the non-sparking aluminum VEU probe. I just want to touch on the fact that you want to make sure that these perforated holes within the VEU probe are set below the cap that is preventing the natural gas from getting to atmosphere. When I mean cap, I'm talking about having these holes below the concrete, asphalt, clay, or frost. The other thing you want to make sure you are doing is having this cup seal to the top surface, sealing to the concrete or asphalt, and making sure that this cup is down. And each VEU hose that is daisy chained in between and connecting to the VEU has ground wire going through it. Now the VEU is up and running, and all the VEU probes are in the on position, and the valve on the 1¼ port is now open. For example, what do you do in the instance when the sensor itself is in an alarm mode, in a low alarm or high alarm? Well, there are a few things you can do for tips and tricks. One would be you could add more VEU probes into the ground. That'll induce more fresh air to dilute that gas mixture down to a safe level. Another thing you can do is dial back the valve and turn it off a little bit and close it. That'll reduce the amount of vacuum going through the unit. The other thing you can do is you could take off one of these caps if you're only running 6 and just open up this valve a little bit and induce fresh air straight into the unit, and that also could drop the LEL levels on that LEL sensor to a safe level and get rid of that alarm. Now as you're running the unit, you'll see green, yellow, and red lights that correlate to what is going on within the unit to this sensor here. Now I'd like to talk about the pump oil spot right here. This is where you will put WD-40 or any approved substance into here to lubricate the blower. By lubricating the blower, it'll ensure that the blower itself will have a longer lifespan, as well as the coupler will last longer. For daily maintenance and our service manuals, you can go to our website, www.mbw.com, or you can scan our QR code right here, and that'll pull up our manuals and or our training videos on the vapor extraction unit. Within the manual, we have a daily service maintenance schedule that goes over what you need to do throughout the year to keep your machine running. And now we're on the final step, the calibration process of the VEU sensor head. So one thing you want to make sure you have is the calibration gas, which is 2.5% methane and 50% LEL. So now you take your magnetic wand right here, and you're going to cycle through until you find the C for calibration. And there's the C. Now you're going to swipe channel 2 and hit enter. Now as you can see, the number on the bottom right corner is counting up. We recommend during this time you connect the gas, but do not turn it on, and wait until it counts up to about 75. So now I'm going to take the bottom cup off, put it off to the side, and connect the calibration gas. And once again, we're waiting for it to count up to 75. So when it hits 75, I will turn on the calibration gas. And now I will turn on the gas, and you're going to see the number on the upper right that is flashing go up. That is the gas going through the sensor head and is beginning to do the calibration process. One thing to note is If you do not have the calibration gas and you enter the C for calibration, you will want to unplug the sensor from the machine and it will reset. And it will not harm the sensor itself. So now we're just going to wait for the number on the bottom right to stop counting up and start counting down. And that is when we decide to disconnect the calibration gas. Now I've removed the cup and turned off the gas. And if done properly, the sensor will read a 0 when completed. And the sensor reads 0, you have completed the calibration process. We do recommend that you do this 4 times a year within the service manual. And one last step, after you have completed the calibration, make sure that you take the time to wait for the VEU to warm up before you begin the process of running. For a more in-depth look at the calibration process, please check out our YouTube channel and search for the calibration process video.